Yes, I'm
Okay,
sharing
sir.
the screen. Yeah.
Thank you, sir. Thank you.
But madam, it says the host has disabled participants from sharing. You may have to allow me to share this. Technically, you know.
Ah.
And in the meantime, thank you very much and welcome to all of you, very senior scientists and experts from the entire IIR and ICAR system. And I'm very happy. And I thank also the Indian Institute of Rice Research for giving this opportunity to talk about to a larger gathering about of scientists of this technology of drip fertigation for rice cultivation.
I have a request to all the participants. If you have any questions, put it in the chat mode. Dr. R.M. Kumar will be the moderator. He will take the questions in the end, and we will ask Dr. Suman to for the replies. So please let the lecture go on and put all your questions in the chat box. Thank you.
Just verifying, can you all see my slides?
Yes, sir. Yes.
Okay, so I'll continue.
Yes.
I once again thank all the participants who joined this meeting as well as IIRR for providing this opportunity. Now, I was asked to actually talk about not only rice cultivation with the drip fertigation, a part of the drip science, which is the crop water relations and soil plant water relations, how it affects or how it is utilized for drip irrigation. So there will be a mix of these. I try to combine the topic rather than making two different topics, because the topic is that crop water relations topic and soil relations is very critical also for deciding on the appropriate drip irrigation for rice. Now we can just enter into the idea of what is irrigation and the progress in technology, which as I mentioned here, shown in the picture, you have a classical flood irrigation, but just by cutting the bund, the water enters, and if you have provided a gradient to the land, water flow from one end to the other. Then we have more controlled, which you have ridges and furrows, where a controlled flow is there. Then we have sprinkler irrigation, which is a pressurized irrigation, then more appropriate and regulated irrigation, drip irrigation. And drip irrigation itself now, at least for the last 10, 11 years in India, we are also doing subsurface drip irrigation. So that's the sort of progress. So what happens is that in this progress, what is hidden is from a large volume of water, the crop uses what it requires in the flood irrigation to a situation in drip irrigation where water is rationed or calibrated amount of water is given based on the evaporation of the location as the crops and the ETP of the crop, that is the crop water requirement. So that sort of thing change has happened over the years. Now, where does the water go? Many farmers used to ask me this question. I closely work with farmers, by the way, at least when I started working with Jain Irrigation for the last 22 years. Why we apply this volume of water in a rice field, as you can see here, and what are the requirements which the crop requires, and where are the other places the water goes? Only two, the green ones, the transpiration from the crop and the evaporation of the soil surface. These are the only two components the crop uses, or crop means the plants and the standing land, exposed land also evaporates, because that is, you cannot stop it till you get the canopy to cover totally. Then only the transpiration becomes more dominant and evaporation of the surface becomes lesser. All of us know wind drift, evaporation from the surface of the water, infiltration to down, and deep percolation, runoff, etc. are wasteful use of water basically. Now, but this is nothing wrong with it. At that time, when irrigated agriculture started, we didn't even know that the transpiration and the evapotranspiration of the crop, including the land it stands, is the component which the equivalent to crop water use. That's because we didn't know that. The second thing is that even if we knew that, later we came to know about these things through studies of physiology, crop physiology, and all that. Hello, can I continue? when we came to know this is the only thing, then we didn't have a technology to apply only that component to any crop. I'm not talking only about rice here. Now we have a technology. Drip irrigation by definition as well as by practice is actually isolates the component of ETP, evapotranspiration, and when properly using the weather data of each location, when properly estimated, it can give only those two components of irrigation water, and that's exactly what it is. And it has been like that for several crops. And long back in 2006-7 or so, I was just thinking about it. Why not we try this on rice also? So that's what the result of this whole number of years of studies and the results which you are going to see. So we are talking about irrigation equivalent to ETP of the crop. Now, what is drip fertigation? Drip irrigation is simply the calibrated application of water and incidentally nutrients also, water soluble nutrients also, through a special polymer tubes called the drip lines, and drippers, with the drippers emitting it close to the plant root zone. That's basically the theoretical definition of drip fertigation actually. Water and nutrients are applied at frequent intervals, of course. It's not like a flooding once in 7 days or once in 6 days or once in a week, whatever. This is actually applied almost every day. Every day we have to apply because you are replacing previous day's evaporation from the crop and the land by today morning irrigation. That is sort of principle of drip irrigation. So you are irrigating every day. Maintenance of field capacity by daily drip irrigation makes the plant to grow without cyclic stress. No, that's what it is. The pink line shows the drip irrigated moisture status in the soil, where there is a little fluctuation, but it remains at a level close to the field capacity of the soil if it is properly estimated and applied. While the flood, you can see the blue lines, you have the ups and downs, extremes of high and low of water based on the interval of your irrigation. Now what happens is that particular factor itself provides the crop cyclic stress. The crop, whichever crop it is, it cannot have full growth potential even at both at the extremes, extreme high and extreme low levels. This is what drip irrigation takes away from the system, and that is the reason when irrigated crop is converted to drip irrigation, you get a higher yield. Now we need a water source. I'm just going through the drip, the basics about it. You all know about it, but then I was trying to structure it in such a way you will have a comprehensive picture. Your water source can be borewell, because many people have doubts whether you need a canal or you need a well or whatever, or you need a sump. People used to ask, do I have to raise a 10-meter high sump to drip irrigation? Even now they keep asking, even though India is the largest area under drip irrigation in the world now. So we can have a borewell, open well, ponds, farm ponds, village water tanks, streams and river. Any of these can be used as the water source. Now you need a power source also. Drip irrigation is a pressurized irrigation system. You are pumping the water, letting into the system. So drip irrigation probably look in a normal way, where we do drip irrigation for an average farmer in India. We need about a pressure at the starting at 1 kg pressure. 1 kg pressure. That comes from, of a small farmer, it comes from a 3 HP motor to pressurize the system. Now you can have, because for the same amount of irrigation for using a sprinkler, you need a 5 HP motor. You need a higher pressure because you need 2.5 kg pressure for a sprinkler. And of course there are large sprinklers called rain gun, which needs about 4 to 4.5. So what I'm trying to tell you is the power requirement of drip irrigation is the lowest among the pressurized irrigation systems. Then you have to have a clear idea about the soil plant water relations. It is not just putting the pipes and tubes and the filters and the fertilizer injectors in the field that is much drip irrigation working. Drip irrigation, to do successfully and get the best benefits in terms of water use as well as yield, you have to understand the soil. Here, especially soil plant water relations, when I say, it means the movement of water, the retention of the water in the soil, as well as the use of water by the crop. That's the three components have to be understood. And these factors are actually considered in the designing of the system also. The design engineer and the agronomist discusses this, and then they understand this completely, then only a proper system can be designed. An irrigation engineer should primarily be concerned with the water holding capacity of the soil, particularly in the plant root zone, and the water intake of the soil. How much water, when you apply water from the surface, how much water goes into the system and remains in the rhizosphere. That's a very important factor, deciding the precision of the irrigation. And of course, we should know the ETP of the water. That is the amount of water the crop uses. And it changes over the time. I'll show you that actually. Now, just a pictorial thing, when you are flooding the field, you don't need to think about any of these. You need to have a gradient of the land so that from the starting point to the end of the field, the water can flow. That's all you need to think about it. But when it comes to drip irrigation, the other two so you should know the soil texture mainly. I will come to more detail of that point. Here the water is generally coming out of the dripper. It spreads and you get the top photo starting and the bottom photo of the drip line shows the spreading of the water. They are very different from the spreading as it happened in the flood. This spreading and the rate of water spread and the width of the spread all depends upon your actual assessing the soil quality, the soil property. That is where we have this issue of soil texture versus structure. Texture is more important for a drip irrigation practitioner to put a system properly in the ground. Texture is the various size distribution of sand, silt and clay in the soil percentages. That's the texture, while structure is actually the aggregates. Now, these are all very basic, but I'm just trying to bring out an idea using this basic knowledge. You have sand particles, you have a clay, which is the glue clay, that's why I use a potter's clay here, and then you have some there between silt. Sand, silt and clay, that forms part of whatever fraction it forms. You get a loam. Loam has got all the three. You have a sandy loam when sand is more, you have a silty loam when silt is more in percentage than a clay, and a clay loam with the clay is more. Why this is important, you will come to know later. The drip irrigation is a point source. Water is coming through a emitter device, and in a clay it spreads. Vertical movement is lesser. In a sand, vertical movement is rapid, spreading is less. And in a loam, which has got suppose clay and sand more or less equal, then you get a bulbous shape actually. Now this is important not only to know this is important factor deciding the cost of the system. Because based on this only you are deciding what is the distance between two drip lines you should provide to the farmer in that particular field. So that is why we first ask them, or we take the soil and do the textural analysis and then decide the drip lines. And what is the distance between two emitters on the drip line is also decided by the soil texture. And what should be the rate of emission. In a soil with a sandy soil, suppose you give about 8 liters per hour emission, you are only losing the water down like a funnel into the profile, and the roots are far away from them. Roots will be at the top, water will be reaching. So that is important. The emission rate also has to be decided. Now that's what I have clearly. Clay is usually densely packed. The porosity will be low because you have more micropores. But one of the good thing about clay is that it holds the water for a longer time. Holding duration will be more. That's it. In sandy soil, on the contrary, holding will be less. You have larger pores, but they dry out quickly. The holding duration will be less. And loam will be somewhere in between of that. Now, this basic soil physics picture is actually the Bible for drip designing. And you may wonder why I dug from old books and brought it. Here on the left side you have the sandy soil and how from a point source water moves down, and it takes about for 24 hours to reach a 1.5 meter. But the same amount in the clay soil on the right side, you have the wider spreading, it takes 48 hours to reach that depth. That's the sort of thing. So that we all know that percolation, soil percolation rates vary with the clay content. What is more important is that the lateral spread will be more in the clay. So a farmer having clay soil can have a drip line put on, let us say 1 meter each on each side. While a sandy soil, that's where the economics come, the cost of the system comes. A sandy soil farmer will have to have a drip line at every 50 centimeter or 60 centimeter. So per hectare, the line load will be more in a sandy soil versus a clay soil. This is just to understand. That is why It's a tailor-made system for each farmer, and the cost will always vary from farmer to farmer. This is the basic reason for that. The idea is that uniform wetting. To achieve uniform wetting in clay soil versus in a sandy soil or in a loamy soil, the requirement of systems, number of drippers, rate of dripping, and the drip lines are different. Now this is the example. We need to get the left side. By the way, this is actually a Punjab rice field. All the photographs are from rice farms only. On the left side, and by the end of 6 hours, the water moves because after dry sowing, it's a DSR field. We provide irrigation through drip, and then we make sure that the soil actually spreads uniformly on. Then only you get good germination. After germination, we will then enforce irrigation schedule based on the ETP. Now, have a close look at this figure and see the next figure. The next figure is, this is my experimental field actually, the first demonstration we are doing in Iran. Here is a different type of soil. Even though the drip lines are spaced at 75 centimeter, drippers at 40 centimeter, and 4 liter per hour is the thing, you don't see any surface water at all except where it is dripping. But look at the rows of rice plants. Again, it's a DSR, mechanically planted, machine planted DSR. You see, even the 2 rows in the middle of the 2 lines, where you don't see any wetting on the surface, is getting water. In other words, water actually laterally moves through the subsoil or just below the soil. So that's why I've asked them to take a picture after removing the soil up to about 6 centimeter. And that's where now most of the roots of the little plants are there. Now this is about a week after emergence is completed. That's the thing. The point I'm making is that it need not be those people who are used to see rice fields either expect flooding or expect wet soil on the surface. It need not be so. Rice can still grow. That's the point. Now, why we need rice production? Okay, let us look at rice production and water use. About 1,000 kilometer cube of water is used to produce about 700 million tons in 160 million hectare globally. This is a global picture. And 45% of all the water, available fresh water, is used for rice production, used for irrigation, is used for rice production. That's the thing. So rice is a major water consuming crop. And 50% of the water applied is actually, I'm using the word wasted in the sense that it goes not for the growth of the rice, it grows elsewhere. That's right, yeah. And water productivity comes about 300 gram of raw rice per meter cube, what is 1,000 liter water. Now we have an issue. This is Indian water. This is from the Central Water Commission data. This has not changed. The blue line shows our freshwater cycle, and the brown and the green shows the water need. So by 2050, we will reach, or we will exhaust all our freshwater use. This is actually a very frightening picture, and all of you know that actually. Now our problem is this: in that decreasing water scenario, we had to still produce more rice. Look at the red line which I have written, red line. India needs to produce, this is all GOI data, Government of India, Ministry of Agriculture. India needs to produce 140 million metric tons of rice by 2050. And 2 million tons of additional rice every year for the next 20 years. That's the meaning of that. But that can be done by irrigated area. So you can see the cultivated rice area and the irrigated area. Maybe these figures may change a bit, but there is no quantum change. Quantum jump is happening to it of the irrigated area. We had to irrigate more rice area to get the production coming to 140 million metric ton. That's the message. Now, this is done. This is required to do in a situation where water is decreasing. This is the catch-22 situation. Now, that is in that light only we are talking about drip irrigation for rice. Because why we are thinking about drip irrigation for rice? Lessons from several crops show that the drip irrigation produce higher yield and lower water consumption. And these percentages which I have used, 60 to 100, are coming to think about a lot of crops, not only rice. And some 50 to 70% of water will be prevented from entering the field if you are irrigating through drip. and still get you 60 to 100% yield increase. This is happened with many other crops. So I have started this work in 2007, and now it's about 2020. We are still doing both demonstrations in newer and newer places, newer and newer countries, wherever it is interesting. And then we are also doing research on that with both collaborative and our own research. And it is through such a collaboration of research which I acquainted with IIRR. Now, there is another interesting thing. The blue line in this: reduce the groundwater pollution and nitrate leaching when a high amount of urea is not loaded into the field. Because in fertigation, we use very small amounts more frequently. I will come to that exactly how many times and all that, so that we can reduce the urea load into the field. And when urea is loaded into the field and then it is flooded, you get two things. First, you get nitrous oxide coming out of it, which is one of the GHG, and then you also get the nitrate leaching to the groundwater and the other water bodies. And because drip irrigation always keeps the soil in a way just saturated or just the field capacity, it doesn't give excess water and the anaerobic condition, which will create methane. Now, for all this, we have to be exactly estimating the water requirement of the crop, which we do for every location. This is the equation based on the pan evaporation data. Now, and the crop coefficient, which is actually that fraction of water the crop uses or crop transpires, in a way of speaking, and which actually changes with the crop growth stages. That is in drip irrigation, irrigation is not the same volume all the time. It changes with the crop's growth. From a smaller amount, it increases and reaches the peak, and then it goes down as the crop senesces. For example, in Modipuram, in UP, these are actual values I'm showing. I used to have a 3 years collaborative work with IRRI. At that time, IRRI's local research station used to be in Modipuram in Sardar Vallabhbhai Patel University campus. So we used to work there and drip irrigate it, and there are so many other irrigation systems also we tried there. This is to show one full season rice planted in June and then harvested in October, mid-October. You have, this is the way daily liter per hectare application of water through drip is done. So it is not the same. So it changes with the age. This is exactly one of the first point the farmers have to understand. Because in the mindset, first they will see water. Whether water is there, they always see from the surface. That is not possible now. The second thing, when they apply water, they apply, it is like 8 hours running the pump or 6 hours running the pump. It is same whether the crop is in the first 15 days growth or the crop is in the second month of the growth. So that variation has come. And that is also one of the reason why these technologies are slow in getting into farmers' mind. And I have, because I worked in different parts of India as well as overseas, I estimated the water requirement as per the evapotranspiration, that ETP, for a crop of rice. For example, coastal peninsula, West Godavari district of Andhra Pradesh, for October planting, you need about 5,748 meter cube per hectare. In the interior peninsula and the same Kurnool, which is a bit more interior than the coastal, you get about 5,800 because you get more hotter climate, higher potential evapotranspiration. Southern coastal Tirunelveli in Tamil Nadu, 4,700, like that. And if you go to the north temperate region, Kurukshetra, Haryana, where we do I work on a project there, it's about 3,880 because of the lower temperature and the type of evaporation takes in place is lower than what we saw in the peninsular India. So this way, if you compare this, in conventional irrigation, the whole season consumes 23,750 meter cube. Is actually metered and we measured it, water for a hectare. 23,000. These values on the right hand side column are nowhere comparable to the 23,750 meter cube. So that's sort of water economics which comes when you adopt drip irrigation, and then there is a yield also. Now, coming back to trials, to into more details, these are all published information. I'm just showing you. We have this is my second trial, 2007 I started, 2008 it is. With the flood, I have used 23.75 million liter per hectare water, and drip used 8 million. and that's a water economics difference is about 66%, and I got a marginal increase in yield, 7.1 ton of the same variety gave 8.6 ton in the drip. Apart from this, one other thing, the power use, electricity use, it's 11,000 versus 5,650. And we also went into to do the yield component analysis, a typical agronomy trial. You have in drip, you get more productive tillers per hill, and then more grain, and a very slight increase in the 1,000 grain weight. And this is water productivity. If you have flood irrigation, you get about 0.13, 130 in the trial which we did, gram per 1,000 liter water, kilogram per meter cube of rice. I have taken some data from to find out the SRP, where you have the 0.47 and the drip gives about 0.55 kilogram, which is 550 kilogram. Just to give a comparison on that, the water productivity of rice. Now we have then what have done, we did a lot of tests in all across India, and then come up with a package, and that's the package I thought I will be talking to you today. Now there are two ways. The first question one may ask is that, is it only DSR or is it transplanted? Okay, now this technology, as we did in Andhra, we did several places in the Godavari districts, we did transplanted rice also. Transplanted rice with the drip irrigation. The difference is like this. First, in direct seeded, paddy is first planted in dry seeding or transplanted. That's the method of planting. In dry seeding, seed first and drip irrigate after the planting, because either it is manual planting by labor or by planter. I'll show some planters which we use in the process. In transplanted rice, what happens is that we create seed bed, we wet it and then transplant it. But please understand, in the transplanting, in this case, there's no puddling. The operation of puddling is not there. Only difference is that it is wetted with the drip before planting. And of course, there are different spacing. I'll come to that. Then one of the major threat or the challenge we have is the weeds, which all of you will ask me the question, what you will do with the weeds? Because in standing water, when the rice stands, weeds won't come, or weeds come less. So we had worked out, and then certain schedules of weedicide application, pre-emergence and post-emergence. Then we drip irrigate till 15 days before harvest. As I noted, it is started from 2007, and over the last 12 years we have been moving around the country and doing it. Now, land preparation, all of you know that actually. We don't want much clod, so we do a final rotavator, because if you have more clody field, water movement through the soil, texture for which you have studied the texture, will be difficult. So you have to look at it. And then conventional application of FYM or vermicompost, whatever, etc. Now, for a rainy season crop, it is advisable to use broad bed. That is just a suggestion. Some farmers agree to that actually, because then they can drain off the excess rain comes into the field, and that doesn't create thing. Okay, obviously when the rainfall is more than 20 millimeter a day, we ask them not to irrigate with the drip. There's no need for wasting water with it. And for rabi and summer crops, even flat seed bed is appropriate. It's only a suggestion. We go with the farmers what they choose. And if you are going for BBF, that is broad bed width will be either 80 centimeter or 100 centimeter, height will be 15, and furrow will be 20 centimeter. And we found out that for nursery planting, that means you are planting, this is for transplanting. You do 50 to 65 kg of per hectare open transplanting. Then direct seeding 40 to 50 kg in the delta. This data is collected in the delta, the Godavari delta, of course. And for direct seeding with Goru, it's you all know that it's actually an implement used in Andhra Pradesh for planting, and we use a machine planter, slightly higher seed, because your seed to seed distance or hill to hill distance are less controlled. You have control only a row to row distance. Now this is on the flat bed. Then we need to think about the drip lateral placement and spreading of the water. In the line, drip line 12 or 16, you use it. If you have a heavy soil, which is more clayey, In such cases, we will either keep it 0.75 centimeter between two laterals, or some cases even 1 meter. It successfully worked actually. But if you have light soil, more sandy and towards the sandy side of the soil, then you do with 60 centimeter, or some place even 50 centimeter spacing. That's what you see that. And the photo on the right hand side top shows you after planting is a DSR from one drip line how the water spreads and how the wetness is. The wetness have to be maintained till germination is complete and emergence is complete. You have to first establish a good population. That's the idea. And on the left hand side you will see the bottom. This is our soil, which is more of a sandy and Moram type in Udumalpet near Coimbatore, where I did first initial trials. So I had used two drip lines on each bed. Now again, these are all basic. Some of you would think that I'm simply putting things already known. 100 to 110 days we try to do 15 centimeter, 20, 15, 25. These are the row to row and plant to plant distance. And we have found out that in light and submarginal soils, because the tillering will be lesser, we go for 15 centimeter. This is more important, weed management. What we have standardized over the period is that we use a pre-emergence 2 to 3 days after planting, if it is transplanted, or after sowing. In the DSR we use these two, one of these chemicals, and then we do a post-emergence another 2 weeks later, which allow the other weeds also to be this is how it is. And some places we still had to do, we did actually one hand weeding to complete the within the 30-40 days time. That is how a weed is managed. So it is flexible, but this seems to be working generally. Now then we went into a lot of multi-location places where I won't say trial, because I'm not working in research fields in this case. It's actually farmers in different states where we, through our contact, our talking to them, they agree. So I got the soil type: sand, silty lake, loamy, garden type, quails and red, all types of soil. Season also June to August, rainy season, then the rabi rain of winter season, then March, June, summer. And most of them are small holders, hardly 1 acre or up to 4 hectare. Actually in Punjab we got a 4 hectare plot to do it. Now this is the grain yield. We could not do much of a monitoring of the flood part of their system, but the drip we know how much water is applied, and this is the yield measured. You can see drip gives about 14 in this case of different varieties. You can see, it has got a lot of things comprehensively inside this. You cannot, so average you get about 14.7% yield to about some case 30% across varieties compared to the flood treated thing. So this is the way this has given us two things. One, first point is that yes, drip irrigation can be used for producing rice. Number two, whether it is summer or rabi or kharif season, you can successfully use drip irrigation. Number three, you can use both transplanted rice as well as dry seeded rice also. And the way how precise you control and how precise you carry out fertigation will give you the yield advantage. That's it, higher yield and lower water consumption. Now then we also were doing at the same time a lot of collaborative research with the universities like Tamil Nadu Agriculture University, Panagar, Punjab Agriculture University, UAS, Bangalore, and your institute I just added, IIR, now we are doing it. International institutes, IRRI and IMI. And this two pictures, what you see is the IRRI in Modipuram on the left side, and IRRI now in Varanasi, where we are using actually subsurface drip irrigation for the trial there. There we are monitoring also a lot of details. This is a parallel to what we are doing in Los Banos, where we are monitoring methane, nitrate along in the collaborative trial. There's a detailed study going on there. This is, we are now ending the second year is ended. Of course, COVID has affected our complete involvement in the trial. We could not make visits and all that, but the study is going on. It's a long-term study there. So here, apart from yield and water consumption that we have been monitoring quite well, we wanted to look at other aspects of their the methane emission, the nitrate and all that. And we are also using a lot of IoT. We are using sensors. The irrigation is no longer estimated and done. It's actually based on the actual soil moisture status, monitored through a sensor, and based on that irrigation water is provided. So we are trying to get as much information into the system with the accuracy. This is the field. In IRRI, when I was working in Modipuram, we used to have rice, and after rice it is wheat. So both crops will be monitored. This is, it happened to be in 2010 and all that. It is IRRI's 50th year also. This is our collaborative work. So both Jain and IRRI's logo are there and all that. Then we did with IMI. IMI is irrigation. You know that IMI is based in Sri Lanka, but they have a Indian office in ICAR Hyderabad. So we worked with them, and this is in this field is in Medak, where we did rice. And Angru, at that time it was Angru. Anyway, I mean the Jayashankar University scientists came on a field day to see the crop, and we assessed it, and we got a good response in terms of tillering. More tillers they found, and less chaff. That is important. The unfilled grain was far less. They went through very in detail on those on that field day. Now some data from Punjab, Rajasthan, just taking all across India, different soil type, different state, different climates, different varieties of rice also. We started getting 8.1 ton per hectare, 3 ton in Rajasthan in a sandy soil, low yielding, and 7.5, 9.5 and all that. What is more important is this BC ratio you have, and the water saving and the payback period. Many people ask, if farmer is wanting to invest in the what is the sort of payback period? Even the governments are interested in this, and fortunately, let us say government of Andhra Pradesh and government of Haryana, though they started supporting farmers for the providing drip irrigation for rice. Now we have I'm doing another project with the Vapro, an agency called Helvetas, which is Swiss Intercorporation in Switzerland. They are Switzerland is one of the major country importing basmati rice from North India, especially Haryana, Punjab and all that. So in this we have collaborated with, of course, Helvetas, the Mars, another company. You may know that Mars Chocolate. LT Food is an Indian basmati exporting company, and a lot of farmers actually. So we did, we introduced drip irrigation with the partial financial funding from the Swiss Intercorporation, the Vapro project, and then that is the daily water requirement for that place which I worked out. If you do drip irrigation, but this, please understand, it is a kharif crop, and sometimes the rainfall can be extremely high. Even now it is happening. So you will not have to use drip irrigation. The field will be anyway flooded with the rain. So whenever the rain is not there and there's a gaps, we actually use drip, and also drip is used for fertigation. Now this is the fertigation schedule used there. 60-24-16 is the local recommendation, and then we started using urea, monopotassium phosphate, and magnesium sulfate, and EDTA zinc for the micronutrient, and muriate of potash. With that, I prepared a fertigation schedule for different, and we do up to, if you look at it, for 90 to 115 days fertigation happens in rice. So many of you may disagree with me and even shout at me saying that after the panicle comes out, are you still fertigating it? Yes. That is the time we apply potash mostly, because that's the time grain filling, the transport takes place. It's not only in rice, in several crops. So this is the way we could produce that extra yield which you see. Now this is the water use. We are first talking about the water use. Now I just took the first year's 21 fields, and then metered water in the drip as well as in the parallel flood situation. You see, all these farmers have flood irrigated land plenty actually. The drip irrigated will be about 1 acre or 1.5 acre, for which there is a cost involved, which we are monitoring it. So basically what happens, you got a huge difference in water use. While your flooding use, the average, the lower graph show you 6,300 or so meter cube per hectare for the full season rice. Drip used about 3,000. That's it. Now in 1 or 2 fields, because the Vapro has got that study also, we put AWD system, AWD, they had laser leveling, some of these farmers had, plus the alternate wetting and drying, the IRRI recommended technology. And then we found out percent of reduction in water use in under drip in those fields was at 51%. But when you use AWD, you still reduce the water, but the reduction is 18%. Then I went into AWD literature, wherever it is used, all across countries, including a lot of countries in South Asia, comes about 23.4%. So drip certainly gives you a much higher. I'm not competing with AWD technology. That's a very useful technology. Farmers are adopting it. If the more farmers adopt, it's good. I'm just saying the fact from the literature, or a comparative way, the water use for rice. Now, when you change the water use, there is a power use change also. That's more important actually. If you use the drip, and power use comes to about 1,850, and you have 7,400 units kWh. In this figure, I have given both kWh. The blue color is the kWh units, and the cost of kWh, that's the electricity cost at rupees 4 per unit, will give you the brown color. So the comparison is that drip uses considerably lower power and lower thing. But this may not be an incentive when you talk about Haryana and Punjab, because they say we are getting power anyway free. No, but then scientifically speaking, there is an advantage, and these are the things, some of the things which are highlighting to the governments when we are making presentations. And in this case, yield, there was a Basmati, right, all of them are Basmati growers, and some of them are DSR, some of them are transplanted rice, both are there in this. So overall we got about only 0.35, that is 350 kilogram yield advantage in that project. We are continuing the project now. Now, if you take the water use and water productivity, that's the figures, you get about around 0.38 in the flood in that area for Basmati, and then drip comes to between 0.7 and 8, different fields. Okay, the scatter I have shown you, the water productivity. Then I went back to, just for you to have a comparison, what are the water productivities recorded in for rice by other people. The first one is that using a glasshouse control study, Bowman, you all know who he is from IRRI. He has done as a 2 kg per meter cube water. This is done in 2001. Anyway, I constantly talk to him when I do all these trials and supply data for his verification and all that. And when you do evapotranspiration alone, in the first one is the transpiration together, the second one is the evapotranspiration, where Bastiansen has done, the Dutch water scientist actually. You come to about 1.1 kilogram of rice per meter cube. Then in the flood irrigation, which is the last line, you get about 0.2 to 1.2. That is also published. So what I'm trying to say is that by these technology of drip irrigation, the water productivity you can increase. In other words, you are using lesser water, you're producing more rice. I also looked at a study from Punjab where they looked at, it's actually a research study, very interesting study actually, I don't know, PAU based study. Even flooding you can control. Continuous flooding, 24 irrigations, you get water productivity, irrigation water, that's water productivity 0.29. 1 day drainage, that means after flooding, you drain it and then irrigate it. 1 day drainage or 2 day drainage, 4 day drainage, you can increase the water productivity up to 450 gram of rice. So even in flooding it is possible. So but drip, when it comes about 0.8, 7, 0.55, 0.6, 0.88. So there is some studies done in India on this, because you're all reputed scientists, so you would know that in the flood irrigation also a lot of these studies have been done. So one of them I picked up from Punjab. So we can change the water productivity of rice. Now we had, this is the Haryana cost economics. We produced with the flood you get BC, slightly higher BC ratio. The drip you got a 1.68, and with the drip DSR you get 1.89. I told you the yield difference was very narrow. So drip DSR is better there than the transplanted rice. That's what that is another comparison one would be looking at it. The main thing is that in the transplanted, puddling takes place, and you know puddling, all of you would know that puddling takes quite a bit of water consumption. The other thing we looked at is in this crop is because this is a system crop. It is not just water, rice and rice. What would happen to your grain yield and water productivity of your second crop? In this case, it is wheat. Again, the drip produce more yield for the drip, that is drip irrigated rice followed by drip irrigated wheat. Flood irrigated wheat followed by flood irrigated wheat. That's the way the comparison is done. You have 4.93 versus 4.84 yield, and irrigation quite big change is there. Rainfall is same for both these crops. This is the rainfall happened in the Rabi time, and then you are getting water productivity of wheat also very high, 2.31 kilogram per meter cube to 1.36 in the flood. But if you use farmer practice, we collected some data from farmers. That is farmer flooding and farmer way of fertilizer application. It comes about 1 kg wheat. The same variety SD 2967. This is to show that when you are adopting drip irrigation for rice, it's not only for rice, you can continue with your rotation crop, and the overall system gives you an advantage. Now, in this case, we also went through some estimates on methane because the Swiss people wanted to see the environmental impact. All other things I already talked about, the flood drip and the saving and all that. But if you come to methane emission, you will see there is about 49% change. But mind you, this is not measured methane emission. This is estimated based on whatever available values available in the literature. Okay. Now we are doing the measurement in the IRRI detailed trial. Now, so basically what happens is that you are getting yield enhancement, conserve water and energy, pumping energy. Labor requirement is another interesting thing, because fertilizer, you don't have to walk into the field and then apply, or with a machine you don't have to apply. It goes through the drip irrigation system. Labor and methane emission I already mentioned. And another interesting thing many farmers told us is that when you have drip irrigated rice, because the water is now standing and his house is very close to the farm, mosquito population is reduced. But then this requires a large number of trials, and then but this is also an important point actually, because there is no standing water, mosquitoes cannot multiply. Now, the long-term perspective is that sustainable resource use in rice production, that's the idea, and ensure food security through water and energy security, which most of you would be talking about. We have challenges. One of the first challenge in this technology moving is weed control. Pre-emergence, post-emergence, we decide we are using it, but then there are variations, and this has to be there has to be some sort of conclusion on this actually. This can actually do. The other thing noticed is that some places, based on some poor soils, we started getting zinc and iron deficiency, which obviously we could overcome that, but that efficiency, zinc and iron deficiency is a matter of concern in some of the cases. And the major point, that's why I put 1 to 1. I didn't put 1 to 3. You would have noticed that. It is farmers' long-held belief that rice can grow only in standing water. That mindset slowly have to change. There are certain researchable issues. I thought you're all scientists, so we are also looking at some of these things. One is the identification of rice. If there are rice varieties more suited for drip irrigated cultivation, that identification is an area of research. Maybe PhD students or MSc students can do. Then again, issues like a methane emission and nitrate leaching in a more detailed, more multi-location and thing, it will be quite good, not only from the point of view of rice production, but from the point of view environmental protection, climate change and all that. You can extend it to any amount. Another thing is that how does drip method irrigation affect pest occurrence? I put this actually, I'm just going to stop. It's only one more. Because 2 or 3 of our farmers, especially in Tanjavur Delta, it is their observation. When they adopted drip irrigation, they found the brown PBH occurrence is lesser. It is only a casual observation made by the farmer. One farmer even sent me a photo, his field protected with a drip, and all around the other fields, in his neighbors' fields, high incidence of this pest. So we thought that may be a good idea to look at in a more detailed way. People can study this. And then another interesting thing is whether precision irrigation creates any change in the grain quality of rice, because this is one interesting thing. And a lot of work is on grain quality is now being done in Varanasi by the IRRI setup, and I know in Indian system also many places. So this is one other interesting thing. And of course, finally, breeding of rice for higher water productivity. That can be a huge issue. It can be practical also. I thought because I'm now talking to a group of eminent scientists, I thought this thing I can put it there. Thank you very much. Madam, I finished.
Sir, you can unshare your presentation, sir. Padmakwari.
So now the topic is open for discussion. Sir, I request Dr. Mahendra Kumar, Principal Scientist Agronomy, to moderate the session.
Good afternoon to everybody. I think we are class at 12. I thank you one and all, and it was very excellent, sir. Excellent presentation and very good information you have given. And now everybody is thinking of water saving, especially for not all other crops. Now everybody is thinking of how water can be saved for rice cultivation, which takes around more than 60 to 70% of water when compared to all other crops. There are 4 or 5 queries which I will be, I think, giving you for your. But most of them has been covered in the presentation. But still, I wanted to share those queries. One query was, does varieties and their duration have any effect on the water productivity in drip system? This was one query raised by Dr. Soman, sir.
I was muted, sorry.
Oh.
Okay, at the moment I don't have a direct answer to that. This is probably an area where we have done several varieties. Now, first thing I can do is that look at my data again, and then on the varietal duration basis segregate it. But I would also think that to get more convincing answers and all that, we may have to take up this study, because when you work with farmers, I'm working with the variety they are used to or popular in that area, for example. So I was not in putting any new variety to them for this particular. So this can be taken up studies.
Another query is, can we adopt surface or dry DSR method, this drip system? Can we adopt it?
Yeah, in fact, the DSR is the most efficient way of water management, even with the drip. I have shown that where you get higher benefit cost ratio also. Now, from our point of view, we thought that because more people are doing transplanted, especially in Andhra Pradesh, I mean, state-wise, if you look at it, if you go to North Punjab, North Haryana and all that, I find more people are now adopting a DSR there. So I went for DSR, but their DSR is different. They are broadcasting the rice seed. So row to row and all that is a bit of a problem there, even in these basmati fields. So yes, DSR plus, in fact, we are also part of the DSR platform of IRRI, and that we are looking at all these aspects. And one of the treatment in their global trial is the drip irrigation and fertigation. That's why I was telling you, where we are monitoring and applying water based on the actual soil water requirement using sensors. Okay, so yes, DSR would be more ideal, and from my point of view, for management wise, I find DSR is better than the transplanted rice.
Sir,
let me conclude. Drip is very suitable for DSR.
Okay. Sir, one more thing is, when you are calculating that benefit cost ratio, have you taken that cost of the drip also? What is the cost of
it is
drip
amortized for 7 years, that is 14 seasons. That is the life we are giving that.
Okay.
It is taken.
Will the drip system will be successful in all types of soils? Is there any variation in the types of soils? There was some query.
Okay, this again, as I said, I didn't look at, so even though in my total multi-location trials which I did all across India and a few countries overseas, there are different soils happen to be there, but soil wise the data is not charted, and then I looked at it. My feeling is that it won't affect. Only thing, one has to be a bit more careful with the sandy soil, because sandy soil, if you are if estimation of the water is not done properly and dripping is not done very precisely, you may get a crop loss. There is a possibility.
There is one more other query is, can you throw a light on the approximate area in drip system
So far.
in India?
In India, so far about 50-55 hectare. And
Rice
most
is
of
also
that
covered,
is in
sir?
Haryana. Most of that is in Haryana and some in Andhra Pradesh and in Tamil Nadu a bit. This is commercial. You are talking about commercially growing, not the trials or anything. I'm talking about Punjab. We are getting now more and more. Punjab and Haryana. Because in the CADA project, the Command Area Development Irrigation Project, where they are using tank system, that is canal water is collected in diggies, in ponds, and from there it is drip irrigated. And many of the farmers in those command area are all rice farmers. So they were encouraged to do, even the Chief Minister came on in public with that, to do rice with drip irrigation. So most of them is happening in the North India.
I request others to mute, please. Can we also include soil-based systemic insecticides in the studies, sir?
Very much so.
Is there any?
You can do very much. Okay. Exactly like fertigation. If anything root-based or soil-based pesticide you have to apply, you can apply. In other crops, it is done generally. Okay. All soil-based, whether it is insects or when pathogens are controlled, you can do that.
One more query is there, sir. This is a total ecosystem. Can it be sustained in a long run when we go for a drip system, like recharging the bore wells and other things, when we are giving water specifically for the crop only? But total ecosystem, can we sustain it? That is one
now,
query.
This answer to this is something which I faced with many people when I was presenting this in the IRRI Congress, Rice Congress in Thailand. And a few places, and I was invited to do one presentation in Harvard also on this, because the technology, everybody likes it. There is another group of, there is another thought process going on, that when you are flood irrigating the rice, you are actually irrigating the ecosystem also. That water will percolate, join the groundwater and maintains groundwater thing. Now, obviously when drip irrigation, we will not do that. Okay. Now, my question to them was, you are pumping this groundwater using valuable energy at a cost and bringing to the surface, and you are expecting the water to go back. I don't know what sort of water management is that. That was the answer I gave to them. I mean, with no emotions, just asking scientifically. So the same answer I will give. So if you are looking for rice cultivation and rice irrigation as a method to get water for the ecosystem, I thought that is a defeating attitude.
Okay. I think most of the chat box queries have been covered. We can take one or two if it is any specific, because sir presentation was very excellent and very clear cut. And if you have anything,
sir, I have
to clarify. Okay. Akshay, go
Hello.
ahead.
Hello.
Sir, does drip irrigation has as it reduces water use, does it has any effect on the root system architecture of rice plant?
Interesting. Okay. I didn't get much time to look at it, but there are some other people looked at it. Actually, in the drip irrigated rice, at least in one report I saw, they found roots becoming longer. The fibrous roots becoming longer than in the control which had a flood irrigation. Obviously, when the moisture spreads through soil and not as liquid water, then the roots probably have to do more hard work to extract the water or something. That's what sort of, yes. But there is no systematic study yet on that. I would assume that the roots tend to be in the water wetted zone of the soil. That's where it is. And in fact, compared to other crops where we have enough data on this, even if you wet 40% of the root rhizosphere, the crop can grow and produce very well. That is a thing. So there is no difficulty of that. But then let me also bring to your notice another technology parallel in Europe, not for rice, they call it the deficit irrigation. Deficit irrigation is not the field capacity irrigation, where you would irrigate a crop which is something close to the 50 or 60% of the actual water requirement itself. And how you make the cutoff point, whether it is 50 or 60, is based on yield. So your irrigation is parallel with the yield production, and if the yield is getting affected, that point you stop. That there is a lot of study going on, especially in fruit trees, in horticulture crops, and other row crops. It is going on, but it's not done in rice. So I'm trying to explain to you. So in the deficit irrigation, what happens is that if you're irrigating one side of the crop row, then roots tends to grow to that side, and the roots on the other side also will tend to grow to that side, and they get enough water. The crop's water requirement is met. Only thing is that there will be some dynamic change happening to a root system. There are reports on that, papers also on that. But again, in rice, all these are now beyond the infancy. I think I request all the respected scientists who are gathered here, you have lots of work you can do with this to look at the rice. I know I'm not saying that you have done work. You have done a lot of work. That's why you are here. Okay, lots of other areas where you can further look at it. This rice root work is only one report I have seen.
I feel, sir, like if there is a drip irrigation, root is the primary organ which is responsible for soil resource hunting.
Yes.
Soil resource acquisition. So,
yes.
Right from the primary roots, or we will say crown roots, we also have to see the lateral roots and root hairs, so that the resource acquisition from soil, because root will limit itself up to the volume of soil where there is water. It will not move further.
I agree with you. That is what I said. Only thing, the root is becoming, which is not what you are expecting, is more efficient in water extraction, as well as nutrient extraction will not be a problem, because nutrients are given in the water as fertigation. So wherever water moves in the soil, nutrient also lands there. So we are providing a situation, that is why the crop is increasing its yield for the lower water is consumed. So when yield is increasing, you can take it as the final factor of all other growth dynamics happening in the system, the crop system. So roots are becoming, just like I said, the crop is becoming more efficient in water use and fertilizer use. The roots are also becoming more efficient in water extraction and nutrient absorption. That's the way I look at it.
Sir,
thank you,
sir. Somanji,
yes,
there is one query that there is one query that is there any clogging of the water? How this there is any clogging of the water, and there is another. I think what is the quality of water? Is there any problem to use any quality of water in drip system? Is there any problems you have encountered during your experimentations?
Okay, this is of course one standard question I've been getting ever since I started with working with micro irrigation, not only for rice, with all the crops. Let me explain this. The filters provided in the drip system will remove only suspended impurities. Just like we add sugar to coffee, the sugar cannot be recovered from the coffee after you stir it. Yes, if you really go into theoretical extreme, yes, it is possible you evaporate it and all that. Forget it. Any salt dissolved in the water makes the water high EC water, electrical conductivity high, and high, what we call it in extreme cases, saline water. Now what happens is that when this water moves through the drip irrigation, if there is a drip system, if there is a chance of water, the salt settling in and accumulating, that is what the clogging comes. So clogging is not the property of the dripper or the drip system. Clogging is due to the poor property of the water, the poor quality of the water. First point. Second point, if this has been so, initially many people who tried to give drip irrigation in India, I'm talking about 25, 30 years ago, the cases, they probably did not give them a method to solve this problem. That is why it became a magnified problem, a simple problem magnified in Indian situation. No other country asked me this question, by the way. That is also an interesting thing. When you have, and then my Israeli colleagues will agree, Israel has got the worst water in the world. in terms of salinity, and they are the largest drip. Everything they irrigate with the drip only. So how did they manage? In India also, Madurai, Tamil Nadu, Kovilpatti, Tamil Nadu has the worst water. Then I come to Madhya Pradesh. We have done a water analysis all across wherever we are working. So what happens is that based on the electrical conductivity of the water, I will prepare an acid injection schedule. What you are doing is that you are periodically you reduce the acidity of the water from the whatever pH it has. So let us say 7.5, 8 or 8.5 pH down to 3.5 or 4 by injecting acid, dilute hydrochloric acid. This method is actually used in all across, especially in the southern Indian peninsula, where mostly water is groundwater, and the groundwater is highly saline. So yes, drip irrigation, if used with a high saline or a high salt containing water, there is an opportunity for drippers to clog if maintenance is not done as per the schedule we are providing. That applies to rice also. Yes, sir.
Sir, how long it will remain once we install the drip system? How long we can work with the same drip system? Is there any?
Right. Yeah. This is another. See, the drip tubes are actually the one which we are manufacturing and government approved and provided to farmers. The manufacturer gives it a 7-year life. Okay, but there are farmers, especially some of the farmers in Andhra Pradesh itself, Telangana and Karnataka, I have Maharashtra, they use even 12, 13, sometimes 15 years. And I have one farmer takes a pride in saying, sir, this system I'm using is 21-year-old. Okay, so there is a possibility. That is because his maintenance was excellent. That's the idea. Only physical damage can harm it by cutting or by accidental damage to the system. Now the filters can stay 30, 40 years in your farm. Occasionally they require a painting because it is a metal body. So now we started giving plastic bodied filters and plastic bodied fertilizer tanks also because of that. And so the paint, they need a repainting or something maybe after 20-25 years. And the pipes you are burying, the sub-main and main pipe, which is either PVC or a polyethylene pipe, black color polyethylene, can stay as long as you want it actually. That is the way the life is designed. So what happens? Okay, now there is a wonderful opportunity to mention this. There are a lot of farmers in India who started using drip irrigation, especially in Maharashtra, Tamil Nadu and all that. And they have been cultivating whatever crop they are doing it for the last 35 years or so. So these farmers, what they are doing now is, when they complete 10 or 12 years and they think that they have got bored with the drip lines, they just replace the drip lines alone with the new drip lines. So that we call it the replacement market. The replacements have started and farmers understand that. Banana farmers, for example, huge banana production is there with the drip irrigated farmers. So what they don't buy anything else because their filter will be there, a fertilizer injector will be there, everything. They just buy new lateral, the same prescription, okay, the emission rate, the dripper to dripper distance, etc. and then they join it. So that's also happening. So you can comfortably use it for 10 years, the drip lines.
And sprinkler can also be used for rice cultivation. Is it possible? Sprinklers.
Yes, you can. I have used also. We have collected data, and in Punjab we have farmers using sprinkler on one side, drip on the other side also. One issue is that their fertigation will not be precise, and it will spread the fertilizer onto the foliage. And during anthesis stage, if the farmer is known to us, I will ask them during the anthesis stage. The flower opens and they should give a window for sprinkler. They should not irrigate with sprinkler. It is very critical for maize and rice and wheat, 3 crops which we eat. If it is my farmer and he knows about us and all that, I will explain to him which stage he has to stop. When he sees the first flower opening, he should stop the sprinkling for at least, let us say, for about 10 or 15 days. So this is a caution. Yes, farmers are using sprinklers and it is very popular. It can be used. Then fertigation will be a challenge for you.
Last 1 or 2 questions from the participants before we conclude it. Anybody, they can unmute, and because SARR is also having another busy schedule, so please one or two pressing clarifications. Anybody?
Mahendra sir, I was just following up the discussions. I just like to say a few words about the presentation of Dr. Soman. Sir, we have been blessed to have you here and then deliver an interesting talk to all our colleagues who are part of our RISE family. And we are really thankful to you for sharing your insights regarding two potential technologies. One is drip irrigation and also fertigation. And we are all, like say, very much thankful to you for your kind support for this webinar series. So thank you very much.
Thank you very much.
Padma Kumari. Dr. Somanji, very thankful to you, sir, for within a very short notice you have accepted it. We are very grateful to you, sir. Dr. Padma Kumari.
Thank you. Thank you.
Dr. Satyendra, are you there? Dr. Satyendra?
Yes, madam, I am there. Can you?
Please take.
Am I audible?
Yes.
Yes, please.
Yeah. So, on behalf of IIRR and on my own behalf, let me congratulate Dr. P.Soman for the wonderful talk, which was very informative and very relevant to us. I think all the members will agree that the talk was so wonderful, specifically with respect to rice, where we need a lot of water to grow the crop. And the talk was very relevant in a way that we know that there is a national mission for sustainable agriculture of Government of India, wherein a special emphasis is given to save the water, to make the agriculture sustainable, and also to make the rice cultivation in particular sustainable. So let me congratulate Dr. Soman, and we are very thankful to sir for giving a thorough giving us a thorough understanding about the soil, plant, and water relations, and specifically how the movement of the soil moisture it is different in different kinds of soil, and what are the methodologies or the different tips that we can adopt, and the researchable issues in particular for many of the scientists working on rice crop, what are the researchable issues, so that in future we can make this particular irrigation system more viable. I am pretty sure that your talk has given us food for thought, and we should be taking many good points from here for our future research. I'm also thankful to our director, Dr. R.M. Sundaram, for giving us this opportunity to invite Dr. Soman, and our director, he has given us full support and cooperation. So we are very much thankful to our director for bringing this important talk among us. And we are also thankful to the Society of Advancement of Rice Research for facilitating this particular talk, and also Dr. Mahendra Kumar, who is the secretary and also the facilitator or the moderator of this webinar. Thanks are also due to Dr. Shailaja and all the team for facilitating creating the links, and also all kind of IT support that has been extended to make the talk successful. Let me thank all the participants from India and abroad who have actively participated, raised questions, and also actively involved in the presentation throughout the talk. Last but not the least, Dr. A.P. Padma Kumari, who is seminar committee chairman, and also seminars facilitating this particular talk, and all the committee members of seminar committee. Thank you, one and all.
Thank you, Dr. Satyendra. Dr. Soman sir, we are having also one journal, sir, Society for Advancement of Rice Research. If you can give the an article specially focusing on rice, we are very happy to publish in our review article in our society journal. Kindly, you can take time, sir. Within 3 days, you can also submit a review article for our society. Thank you, sir, once again for your time.
Thank you very much. Namaste.
I
Thank you,
just
sir.
want everyone to put on the video once for a screenshot, please.
1 second, sir, for screenshot for
Oh, okay.
photograph.
Please send me one after you take it.
Yes.
But do you get everybody? Because
Shailaja, is it okay? Have you taken?
Shailaja? Shailaja? Request Shailaja to take a screenshot, please.
Yes, I have taken.
Yeah, please.
Thank you, Rajendra. Dr. Soman, sir. We are having also one general incentive for advanced rice research. If we can give the
Is it over?
article, especially focusing on rice, we are very happy to.
She has said that she has taken already, Padma.
Okay. Right.
Thank you, one and all. The meeting has come to an end, I think. We'll close.
okay, thank you. Namaste.
Thank you, Dr. Soman.
Thank you. Bye.
Thank you, Dr. Amnon.
Thank you.
And from Israel also, thank you. Very interesting.
Go, Benry. Yeah, thank you.
Okay. I have taken.
Thank you.